everyone, and welcome to this comprehensive series on Java Viva Questions. If you're preparing for a Java interview, you know how crucial it is to be prepared for those tricky Viva questions. Let's get started! Let's start with a fundamental question. What's the difference between JDK, JRE, and JVM? These three components are the cornerstones of the Java world, and understanding their roles is crucial. Think of it like building a house. The JDK is your complete toolkit with all the tools you need to build the house. The JRE is like the finished house. You can live in it, but you can't build anything new. And the JVM is the foundation upon which the house stands. It's the platform that allows the house to function. The Java Development Kit, or JDK, is the full package for Java developers. It includes everything you need to write, compile, and debug Java code. It contains the JRE, the compiler, and other development tools. The Java Runtime Environment, or JRE, is what you need to run Java applications. It includes the JVM and the Java class libraries. Finally, the Java Virtual Machine, or JVM, is the heart of Java's platform independence. It's the environment where your Java code is executed. The JVM takes your compiled Java code or bytecode and translates it into instructions that the underlying operating system can understand. This is why Java can run on any platform with a JVM, write once, run anywhere. So remember, JDK for development, JRE for running, and JVM for execution. This foundational understanding will set you up for success in your Java journey. Now, let's move on to the next important concept. Object-oriented programming, or OOP, is a programming paradigm that revolves around the concept of objects. These objects contain both data, known as fields, and actions, known as methods, that operate on that data. OOP is based on four main principles: encapsulation, inheritance, polymorphism, and abstraction. Encapsulation hides the internal workings of an object and only exposes necessary information through methods. Inheritance allows you to create new objects or classes based on existing ones. Polymorphism refers to the ability of an object to take on different forms. Abstraction simplifies complex systems by hiding unnecessary details. Understanding these four pillars of OOP is essential for any Java developer. They are fundamental concepts that are frequently tested in interviews and are crucial for writing well-structured and maintainable Java code. Abstract classes and interfaces are powerful tools in Java, but they often cause confusion. An abstract class is a blueprint for other classes. It can have both abstract methods, which are methods without a body, and concrete methods, which are methods with a body. You can't create an instance of an abstract class directly. You must create a subclass that implements the abstract methods. An interface, on the other hand, is a contract. It defines a set of methods that a class must implement. A class can implement multiple interfaces, achieving multiple inheritance of type. The key difference lies in their purpose. Abstract classes define a common base for a group of related classes, while interfaces define a specific behavior that can be implemented by any class, regardless of its hierarchy. Understanding this distinction is key to writing flexible and well-structured Java code. Now that we've covered abstract classes and interfaces, let's move on to another important concept: method overloading and overriding. Method overloading and overriding are two powerful features in Java that enable polymorphism. Method overloading occurs when you have multiple methods in the same class with the same name, but different parameters. This allows you to perform the same operation on different data types. Method overriding, on the other hand, occurs when a subclass provides a specific implementation for a method that is already defined in its superclass. This allows you to customize the behavior of inherited methods. Overloading provides compile-time polymorphism, while overriding provides runtime polymorphism. Understanding these distinctions is crucial for writing flexible and reusable code. It also shows a strong understanding of OOP principles, which is frequently tested in interviews. Now let's move on to the final keyword in Java. 10. The final keyword in Java is a powerful tool with several distinct uses. It can be applied to variables, methods, and classes, each with its own specific effect. When applied to a variable, final makes it a constant. Its value cannot be changed once initialized. When applied to a method, final prevents it from being overridden by subclasses. when applied to a class, final prevents it from being inherited. Using final strategically can improve code readability and maintainability. Understanding the different applications of the final keyword is a sign of a seasoned Java developer. Now let's move on to exceptions and exception handling. Exception handling is a critical aspect of writing robust and reliable Java applications. It allows you to gracefully handle errors and prevent your program from crashing. Java provides a powerful mechanism for handling exceptions using try-catch blocks. Exceptions are events that disrupt the normal flow of a program. They can occur due to various reasons, such as invalid user input, network errors, or file I/O issues. Java classifies exceptions into two main categories: checked and unchecked exceptions. Checked exceptions are checked at compile time. The compiler forces you to handle these exceptions using a try-catch block or declare them in the method signature using the throws keyword. Unchecked exceptions, also known as runtime exceptions, are not checked at compile time. The try-catch block is the core of Java's exception handling mechanism. You enclose the code that might throw an exception within the try block. If an exception occurs, it's caught by the corresponding catch block. Mastering exception handling is essential for writing robust and maintainable Java applications. In Java, comparing objects can be tricky. The == operator and the quote.equals methods serve different purposes, and understanding their distinction is crucial for writing correct and predictable code. The == operator compares memory addresses. It checks if two references point to the same object in memory. The quote.equals method, on the other hand, compares the content of objects. It checks if two objects are considered equal based on their internal data. Understanding the difference between == and quote.equals is a fundamental aspect of Java programming. It demonstrates your attention to detail and your ability to write correct and predictable code. Inheritance is a powerful mechanism in Java that allows you to create new classes based on existing ones. This promotes code reuse and reduces redundancy. The new class, called the subclass, inherits the fields and methods of the existing class, called the superclass. The extends keyword is used to establish an inheritance relationship between a subclass and a superclass. The subclass can then add its own unique fields and methods, or override inherited methods to provide specialized behavior. Understanding inheritance is essential for writing well-structured and maintainable Java code. It promotes code reuse and reduces redundancy, leading to more efficient and organized projects. The super keyword in Java is used to refer to members of the superclass. It provides a way to access superclass constructors, methods, and fields from within a subclass. One common use of super is to call the superclass constructor. This is often necessary to initialize inherited fields. Another use of super is to access overridden methods in the superclass. If you override a method in the subclass, you can still access the superclass implementation using ."super.method name". Understanding the super keyword is crucial for working with inheritance in Java. It allows you to leverage the power of inheritance while maintaining control over the behavior of your subclasses. Java's automatic memory management is a key feature that simplifies development and prevents memory leaks. The garbage collector automatically reclaims memory that is no longer being used by the program. Java's memory is divided into two main areas, the stack and the heap. The stack stores local variables and method call information, while the heap stores objects. When an object is no longer referenced by any part of the program, it becomes eligible for garbage collection. The garbage collector periodically scans the heap for unreachable objects and reclaims their memory. Understanding Java's memory management and garbage collection is essential for writing efficient and reliable applications. It allows you to avoid memory leaks and optimize performance. Thanks for watching this comprehensive series on Java Viva Questions. I hope you found it helpful in your preparation for Java interviews. Good luck with your interviews, and I'll see you in the next video.